Okay, hey everybody. In this video, I'm going to talk about logic gates. I'm going to show you AND, OR, XOR, and NOT. We're going to draw them in a diagram style, and we're going to rig up a bunch against each other and see if we can figure out how they would process some input data into, some logical output. Okay, so for starters, let's just go over what the gates look like. If you don't know how these gates work, check my previous videos because I've explained them there. Here I'm just going to sort of try to draw them and make a little circuit area that we can play with. Okay, so AND. Okay, you know what? You want me to? I'll just do a quick recap. The AND gate just means that both bits have to be a 1 in order for a 1-2 output. So if we do a 0 and a 0 and a 0 and a 1 and a 0, a 1 and a 0 and a 1 and a 1, then only this one is going to end up being a 1. Everything else is going to be a 0. For the logical OR, it's going to be if we do 0, 0, 0, 1, 1, 0, and 1, 1. And if this is too fast and confusing for you, see my other videos. But basically, it's going to be a 1 for those three, because if either of those bits are a 1, then the output's going to be a 1, and the only place it'll be a 0 is when both of the bits are a 0. Okay, so then let's look at XOR. So XOR is basically, it's an OR, except this one position right here where both bits are a 1, that would end up being a 0. So for XOR, 0, 0, 0, 1, 1, 0, 1, 1, it's going to be a 0, and then a 1, and then a 1, and then a 0. So it's just a little bit different from OR. And then NOT just inverts the bits. So we'll take one bit at a time, and it's just a 0 becomes a 1, and a 1 becomes a 0. And that's pretty much it. Okay, so maybe I should put NOT right here just to emphasize that I'm talking about NOT. Okay, I'm definitely not talking about NOT. Sorry. So let's draw a logical or a bitwise AND gate. It's basically just kind of like this, and then there's a little flat ridge at the end of it. And it takes 2 inputs. There are many different styles to draw these kinds of gates, but I'm going to use the ANSI style, I think, for the most part. So just keep in mind, you can draw these in many different ways. It's going to take 2 inputs. Imagine this is a little circuit right here, and it's going to give you 1 output. So if you imagine what we talked about before, we could send it 2 different bits, and it will produce the output for us. So if we give it a 0 and a 0, then it's going to output a 0 for us. If we give it a 0 and a 1, it's still going to output a 0. If we give it a 1 and a 0, still a 0. If we give it a 1 and a 1, then finally it'll actually give us a 1. Okay, so that's just the way that gate looks. And now I'm going to draw the next one. Let's draw the OR. So maybe I'll put OR here. Whoops. Oh, I got to do that. OR. So the OR gate kind of looks like the AND gate, at least in the style that I'm drawing. Except the flat ridge is more curved, like this. So, an AND gate, I'll draw it in red just to remind you that this is not what we're doing right now. It's, flat, right? Whereas the OR gate, it has a curve. It's like a crescent moon, kind of. It still takes 2 inputs. So I'm going to do an input here and an input here, and it still has 1 output. And so if we're just going to give it a 0 and a 0, it's going to output 0 for us. If we give it a 0 and a 1, it's going to output a 1. If we give it a 1 and a 0, it'll still output a 1. If we give it a 1 and a 1, it'll still output a 1. Okay, that was pretty easy. Let's look at exclusive OR. So XOR. XOR. The XOR gate looks like the OR gate, so I'm going to start by trying to draw an OR gate as best I can, which is not good. Oh, God. Let me start over on that one. Let me try one more time, and then I'll just give up. Okay, do this, and then I'll say, okay, that was good enough. And then it has another line right here. The line is supposed to be parallel to the crescent moon, the curved side, but not really touching it. And that way it sort of looks like the inputs are passing through like the first line before they touch the actual ridge. So that's an exclusive OR. It also outputs 1 bit. So just practicing, we'll give it 2 zeros. It's going to output a 0 because there's no OR involved. in 2 zeros, or I guess there's no orness to the 2 zeros. If we give it a 0 and a 1, then that's going to output a 1 because exactly one input is a 1. If we give it a 1 and a 0, same thing. Looks good because one input was a 1. But then once we get to 2 inputs, then it's going to output a 0 because the exclusive OR demands that only one of the bits is a 1. And actually exactly one of the bits is a 1 to produce a 1. Okay, so then the next thing that I can show you is a NOT gate. It's sort of like a little triangle here. And again, there are different drawing styles. It takes only one input, and then there's like a little circle up here on top. And then it outputs at the top. And so if we give it a 0, it's going to output a 1. I guess I could draw it a second time, since there's only 2 things we can input to it. It's going to give us a 0 if we inputted a 1 into it. So it just reverts. It's an inverter of bits, of 1 bit. So I hope this helps you understand the basics of these types of gates. Now I'm going to try to make a bunch of them, see if I can come up with something interesting on the fly. I had problems with the drawing system on my other computer, so I didn't really prepare an example. Hopefully this is good. You never know. I'm just going to draw an AND gate here. And I'll say that it takes 2 inputs, because that's what it does. And then right next to it, maybe I'll do an exclusive OR. So I'll do like an OR gate here, and then I'll do the exclusive OR part of it, and I'll give it 2 inputs, because that's what they take. And then next to that, maybe I'll just do a regular OR. We'll say OR, just like that. Oh, that's awful. Try one more time. I'll just do this, and then say this. Okay, that's acceptable, sort of. We'll do 2 more inputs there. And what else can I do? Should I do another exclusive or an AND? What do you think? Vote. Just kidding. I'm going to do an AND right here. So I'm kind of repeating one of the gates. Let's see. AND or XOR. Not, yeah, that's all I wanted to talk about. Okay, so now we can combine them, because remember, these have an output, but if we sort of use the outputs of 2 of the gates as input for another gate, then we can sort of like chain our circuits to make something a little bit more interesting. So maybe here I'll do an AND. I'll say this is an AND gate. Oh God, that's awful. One more time. Okay, yeah, my text-to-speech engine, who I've given the personality of Mary Poppins, is telling me that a door is open. So I've got to close the door after this video. Anyway, yeah, I have like an LLM server in the other room, and so now my home assistant is a little bit smarter, and sometimes she messes with me. That's a story for another video. So I'm combining the output of both of those gates and sticking them into an AND, and then I can do the same thing here. I think I drew it like way too high. I'm going to run out of room. Let me try one more time. Put that there. We'll do an AND gate, like that, and then I'll just maybe curve the wires so it seems like it makes more sense. Okay, and then maybe over here I'll do, I don't know, maybe this should be an OR. I'll do an OR gate, like that, and then the inputs from the other ones go into the OR gate. Then these 2 can combine to one more, so maybe I'll do exclusive OR, I guess. I'll just put an OR gate here, and then I will. That's not curvy enough, is it? I like my XOR gates nice and curvy. So we'll do this, and then I'll put another line under it, and then we'll connect these 2. So we'll do this. Okay, so then finally we have like 1 bit that's going to come out at the top. Let's use the NOT gate, might as well. So I'm going to connect this to a NOT gate and put a little circle on top of it, and then it will give us our final output. And maybe I'll stick it here in green or something like that. Okay, so there's lots of different input-output combinations we could use. Let's see, for every input we have, that's 1 bit. So 1, 2, 3, 4, 5, 6, 7, 8. That's 8 bits. That means I could draw out 256 possible input combinations, which I'm definitely not going to do in this video. But let's just do some random stuff. Let's start off with zeros. just for fun. So we'll do a bunch of zeros here. So if you sort of look at this diagram, we go, all right, what was that? This AND here, there's two zeros, it's going to produce a 1, so I'm just going to put a 1 right here to remind me that a 1 is going to be the output of that gate. And then the OR gate here is going to also output a, what am I doing? Why did I put a 1? A 0, because 0 and 0 is 0. And then 0 or 0 is also 0. So this is going to output a 0, and then this exclusive OR is also going to output a 0. And then the AND is 0. So I just have zeros at the next level. Then we look at the inputs here to this AND, that's obviously going to be a 0, and then we look at the OR here, that's obviously going to be a 0. And then those two go into the gate that's a little bit higher, and it's going to output a 0 because exclusive OR needs at least, it needs exactly one 1. So it kind of feels like it's going to be a 0 for the output, right? You'd be wrong if you thought that, because the NOT is going to invert it. The NOT is going to take that 0 and flip it to a 1. So if we do all zeros, the answer is actually going to be a 1. Okay. Let's reset this and try again. So I'm going to just get rid of these greens here. And then I'm going to do, maybe I should write the inputs in red so they're more fun, so they don't feel like they're blending too much in with the actual diagram. Okay, so now I'm going to, let's try all ones. Let's see what happens if we do all ones. So I'm going to do ones on every input. 1, 1, 1, 1, 1, 1, 1, 1. And so, if we look at this AND gate, it's going to output a 1 because, well, a 1 and 1 is a 1. The OR gate, same thing, because a 1 or 1 is a 1. And then do the same thing down here for this AND. And then the exclusive OR, that's going to be a 0 because it wants exactly one bit to be a 1, not both. So it's a little bit more interesting. And then we go up one level. This AND gate is going to output a 0 because it wanted both of those inputs to be a 1. For it to output a 1, and then for the OR, it's also going to output a, well, it's going to output a 1 again because both of those are 1s. And then if we look at the exclusive OR, oh, that's going to output a 1 this time because exactly one of the inputs is a 1. Then the NOT is going to invert it, so the final answer is going to be 0 for this whole giant thing. I want to say make sense and wait for questions, but I guess I can't. So let's try another example. I'm going to do maybe 2 examples with totally random numbers, and then I'm going to show you how to write a truth table that might help you work this out on paper or like a notepad if you don't really want to draw. So let's see. I guess I'm going to maybe take some of these and turn these into zeros. Let's see, get rid of that, make that a 0, maybe I don't know. I feel like I'm not random enough. Okay, 1, 0. And then maybe a 0 here. How about a 1 there and a 0 there? Just 1, 0, 1, 0, 0, 1, 1. That's too much of a pattern. Let me do a 1, 0 here, or a 1 and a 1. Okay. That feels more random to me. So looking at the AND gate, that's going to output a 0. The OR gate is going to output a 1. The exclusive OR is going to output a 0. The AND is going to output a 0. So we just got a 1 right there. So this AND is going to output a 0 again. This OR is going to output a 1. And then the exclusive OR, it's got enough to output a 1, so that's nice. And then its final output is going to be a 0 because we had to NOT that 1. Nice. Okay, let's just, I don't know, change a couple random bits. I'm going to change this. Well, let me erase first. And then I'm going to start changing random bits. I don't even remember what that last bit was anymore. I'm going to pretend it was a 1, and then I'm going to change it to a 0. And then I'm going to change this 0 to a 1. Then maybe I'll change this 1 to a 0, and then I'll change this 0 to a 1. Not exactly random, it's human random, sort of. So let's look at this. The AND is going to output a 1, and the exclusive OR is going to do a 1, and then the OR is going to do a 1, and then the AND is going to do 0. 1 and a 1, 0 and a 1, 1 and a 1, 0. Okay, I think I did it right. So the OR is going to do a 1, and then I think what's happening is I got to adjust my penmanship style. I still have to lift up sooner so it doesn't change colors. So then the AND, it's going to output a 1, and then this exclusive OR, it's going to output a 0 because it wants only one bit, one input to be a 1. And then the NOT is going to invert it, so now we have a 1 right there. Okay, let's look at the idea of using a truth table to make this a little bit easier to solve if you're just kind of doing this without drawing. So I'm not going to clear this just yet. I might have to clear it in a second. But the first thing that you should do when you're making a truth table is, I mean, I guess you can style this however you want, but you kind of have to think of this hierarchically. Like, what's the easiest thing to do? You don't want to start computing the thing at the very top because that depends on a lot of other stuff that's at the bottom. So instead, I'm going to look at the very bottom row of inputs because they're the easiest to calculate. So I'm going to do and I'm going to say something and something. I guess I'm just going to put and by itself. Maybe I'll put one for input. So for the inputs, I'll just do the bits here. 1, 1, 0, 1, 1. No. Okay. Let's just use 2 inputs only because we're looking at the lowest level here. Yeah, and we'll make maybe like a separate row or separate table for that. So we just have 2 inputs per gate on the bottom row. And so for the AND, it's going to be a 1, right? Then for the 0, 1, well, maybe I should just do this in numeric order. I'll just do every possible combo because we don't have that many numbers. So we have 4 combos. This is like 0, 1, 2, 3. So from 0 to 3 or 4 possible combos. And then the AND is going to be a 0 here and a 0 there and a 0 there. So that's a truth table that just handles that first gate. So then I'm just going to, write, I mean, you could make another truth table for this, but I'm going to try to write this in a more compact way. I'm going to say the second column is the result of ANDing, the next column is the result of ORing, and then the last column is the result of, maybe second to last is the result of an XOR, and then maybe I'll make another table for NOTing. So what is the result of an OR here? It's going to be, a 0. The OR here is going to be a 1. The OR here is going to be a 1. The OR here is going to be a 1. So when you start to make these tables, it just makes it a little bit easier to work your way up. Because when it gets time to, let's say, the NOT, you don't have to compute all the other things because they're already computed in the table. So we got the OR, which I should have probably done first because the second gate was an XOR. I should have done that maybe third. I don't know. I'm going to leave it as AND and OR right now. And then we're going to do XOR. So XOR is basically if exactly one bit is a 1, we'll output a 1. So that's a 1 there, and then a 1 there, and then a 0 there. Okay, so we've got the basics, and if you think about it, that's the whole bottom row, right? So if we're just sort of looking at, let's say, the third gate right here, then we just have to look at input 1, 1 for the OR, and then that's this right here. Right there. So that tells us what the answer would be. Truth table. And then if we're looking at the XOR, for input 0, 1, we just have to go, all right, 0, 1, XOR, the output should be a 1. And we can double check ourselves because it's really, really easy to make mistakes. I'm sure there's a chance that I have or will make a mistake pretty soon. So we did AND, OR, and XOR. Let's do maybe just one for the NOT, just to remind ourselves of what it is. And I'll just say NOT. And so we can only do 2 different inputs on the NOT. So I'm going to go maybe a 0 and then a 1 right here. And then the NOT is going to say we have a 1 there and a 0 there. Okay. So now we can get a little bit more complicated by combining these terms. So for the input now we could do let's say 2 gates at a time. So we'll do the input here and we'll say the input is going to be 1, 1, 0, 1. And so when we NOT when we do an AND for the 1, 1, we can end up with a 1. And then when we do an XOR on the 0, 1, then this is not the best truth table, to be honest. There are better ways of writing this, but I'm just trying to do it. The XOR is going to be a 1. So now we kind of have the results written down here. Let's do another little table. And the way these tables work is you kind of want to to put every possible combination of inputs there, but that alone is going to be so many combinations. I don't want to write it all down. And by the time we get to 8 bits, it's going to be like in the 200s. So if we just look at the next pair of gates, we'll say 1, 1, 0, 0. And the first thing is an OR for the 1, 1. And then the next thing is an AND for the 0, 0. And so I can just write this down and go, all right, the OR is going to be a 1 and the AND is going to be a 0. Okay. So then I can do another level. I've pretty much just handled, the bottom row here. And again, each table is supposed to be filled out for every possible combination of inputs. But I can now just kind of move on to the next row. I can say, what is the result of inputting a 1 and a 1? You could do that, but it might be a little bit better and closer to some other places that might want you to input this sort of thing, to write down what is the result of or what are the two gates that are giving you that input. So if we say, okay, so the first input on the very bottom left, that's an AND, right? And then the next input on the bottom row is an XOR. And if we're trying to figure out, how are we combining those, we could say AND XOR, or we can do, two ampersands. I guess I'm going to do AND XOR, just to keep it in plain English as much as I possibly can. So basically, this is going to have, one result, 1 bit result. And its input is going to be 1101. And so maybe I should do another row here. We can say the AND for the AND is going to, for 1, 1 is going to be that, and the XOR is going to, well, I already wrote that down in the table. Okay, I'm just going to clean it up, because, it's really good in these truth tables if you write down all of the numbers, but I'm just going to do it this. I'm just going to do it this. Maybe we can visually see that there's a 1, 1 going into the first AND, and then a 0, 1 going into the second gate, which is an XOR. I think maybe that's acceptable. So the result of that, if we just sort of look up at this table here, we have, what is the AND and what is the OR? It's a 1 and a 1. So if we AND those two together, that should be a 1. So that means if we AND the AND against an XOR, then that's the result that we get. And then we'll make another little table here for the next layer of inputs. So I'll just do this, and I'll say an OR, and then the operator that combines them is an OR, and then on the right side it's an AND. So then the input to both of those is going to be a 1, 1, 0, 0. And again, you should make another row for every possible combination of inputs. That would be a really smart idea. So then I will say that the OR and the AND for a 1, 1 and a 0, 0 is this, because we already wrote that down in the truth table. So really, we're going to be looking at inputs of 1 and 0. So that means if we're applying an OR to that, the final result should actually be 1. Okay, so now we've got that second row. We just have to look at the second to the last row. So I'm going to go input for an XOR of something else, and the XOR is going to be, oh gosh, it's going to be of an AND. Well, XOR, let's put that in the middle. Let's say AND on the left and OR on the right, and then we'll do an XOR against them. Maybe you could put the parentheses on the other ones. I don't know. I'm struggling with notation clearly right now. But so we say AND exclusive OR with the OR, but then what is that AND happening? Let's put some more parentheses around it, and we'll say the AND ANDed with an XOR. Now we're running out of room here. Can I get this like at the top maybe more? How about that? Okay, that's a little bit better. So we have AND being ANDed against an XOR, and then I put parentheses around that. There are special symbols you can use for this to make it more clear, but I'm not really trying to explain that right now. I just want you to see how the gates work. So we have Then the next two operators are in, oh gosh, yeah, we're XORing against two things. So on the right side, the OR is ORing an OR, and then on its right side is the AND. So maybe I should do, I don't know, I guess I'll put parentheses right there to make it seem a little bit more clear. So now we've basically got an XOR, and on its left side, what's happening underneath it is an ANDing, which is the middle, of an AND on the left and an XOR on the right, and then the right side of the XOR is then the right side of the XOR, that was my LLM talking to me again. The right side of the XOR is it's got an OR on its left. Sorry, it's ORing on its right, and then under the OR, it's got an OR on the left and an AND on the right. Okay. So we've written all these down in a way that's okay, not great, but okay. And I'm just going to do 1101, 1100, and then I'll make another video in the future about truth tables if everyone is super interested, but that's not really what I need to explain right now. I'll make a video where the truth tables look proper and nice and full and all that stuff. So let's do, what is the answer between the, oh, I have to scroll up a little bit to see that. So the left side of the XOR had an ANDing of an AND and an XOR, so that was this right here. So the result of that was a 1. And then the right side was an ORing of an OR and an AND, and that was a 1. So I have two 1s basically. So this XOR is going to output a 0 because it's got two 1s as an input or as inputs. Okay, so then I guess I could copy paste this to make it a little bit easier on myself to write it all out. And I could just say, let's not the whole entire thing to get to that highest level. So again, I can just kind of keep the whole thing copy pasted, and the original input bit sequence, I can just not it. I can just change that 0 to a 1. So let's just double check all our levels here to make sure that I did this correctly. You never know. So the input not, we know what that is for the AND and the XOR. Where's the AND and the XOR? Okay, so bottom left. Oh, what did I do wrong? Input, oh, those were just the basics. Okay, so that's not a combination. Let me just double check the basics. For the ANDing, 0 and 0 and 0, and then 0 and then 1, and then 1, and then here it should be a 1, and then the OR should be 1, and the AND should be a 0, and here the AND should be a 1, and the OR should be a 1, and the X. Okay, so got the basics right. And then on line 15 here, we're looking at an AND and an XOR. I guess I just did both of those at the same time. Okay, so the AND is a 1 and the XOR is a 1, and then the next one, the OR and the AND, it's a 1 and a 0. Okay, and then we're ANDing the AND and the XOR, so that's 1101. The answer should be a 1. That matches the diagram. Okay, and then the ORing of the OR and the AND on the right side, that's a 1, so that matches the diagram. And then when we're doing the whole thing except for the not, it should be a 0 at the top. Okay, good. And then finally, when we invert it at the very top, it's a 1. So keep that in mind. You can build and build and build in a hierarchical manner. I mean, think if I started adding a bunch more stuff on top of this not, maybe if there were a bunch of other circuits somewhere else and they were combining and combining like many layers. This is the sort of thing that could help you. A drawing, I think, is a little bit easier, but this could help you to just draw out a little table. And of course, you want to have a giant table showing all combinations somewhere, just to make sure that you can just look it up quickly. But yeah, okay. So I think this is all I wanted to talk about. Let me just double check. All right. So this is all I wanted to talk about for this video about logical gates and the basics and kind of helping yourself with a little bit of a table. In future videos, I'll talk about a proper table, perhaps, and I hope you've learned a little bit and laughed a little bit at me struggling to do this on the fly without a pre-made example. And I hope you had a little bit of fun and learned a little bit of stuff. And I'll see you in the next video. Thanks for watching. Hey everybody. Thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. You know, sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe, and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. And it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? You know, just send me a comment. Whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness which is coming for us all.